In example 6, we want to find the intersection of the two given lines. Or to put that another way, we want to find the point that lies on both of the two lines. So probably the easiest way to do this is to set the y-coordinates of the equations equal to each other. In other words, I want to set the left-hand side, or the right-hand side of both of those equations to be equal. So when I do that, I'm going to have 2x plus 4 equals minus 3x plus 14. So now I've got an equation that only involves x's, and I can use this equation to solve for x. I'm going to add 3x to both sides. That's going to give me 5x, and then I'm also going to subtract 4 from both sides, which gives me 5x equals 10. Then I divide both sides by 5 to get x equals 2. So that gives me the x-coordinate for the point of intersection. So now to find the y-coordinate, I just need to plug x equals 2 into either of the original two equations. Plugging into the first equation, I'm going to have y equals 2 times 2, which is 4, plus 4, which is 8. And you can go ahead and look and see that if I plugged into the second equation, I'd get minus 6 plus 14, which is, again, 8. So it doesn't really matter which equation you plug into. But I see here, then, that the point of intersection has the x-coordinate of 2 and a y-coordinate of 8. Okay. So now, in part B, it's the same idea. Our lines are a little messier here because the slopes are fractional. But we solve this the same way. We set the y-coordinates equal to each other, and we get 2 over 3x minus 2 equals minus 1 over 2x plus 5. Now again, on these types of problems, I like to get rid of all the fractions to begin with. It looks like I can multiply both sides by 6 to get rid of all the fractions. On the left-hand side, I'm going to have 12 over 3 x, or in other words 4x, minus 12. 6 times minus 2 is minus 12, equals. Now on the right-hand side, I have minus 1/2 times 6, that's going to be minus 3x, plus 5 times 6, so that's 30. Now I add 3x to both sides, and I also add 12 to both sides, and that's going to give me 7x equals 42, or x equals 6. So now I plug this into either of the two equations. It doesn't matter which one. Plugging into the first equation, I have 2/3 times 6, which is 12/3, minus 2. 12/3, 12 over 3 is 4, minus 2 gives me 2. So my point has an x-coordinate of 6 and a y-coordinate of 2. And so this is my point of intersection for these two lines.